Hey, so some of you are having troubles with integers that blow up and just don't work so well. So we're going to show you how to use the BigInteger library that we talked about in class. So let me put that away. If you want to solve my Rubik's Cube, you can come to my office, work on it. It's an original one from the 1980s. Let's see. So let's say we're at the TC101 page. Let's go to that page. Let's just pull this out. Let's just focus on that. All right. Okay. So this is for the C++ folks. Let's go to, oops, I'm failing at navigating here. WSQs. So a lot of you are working on, say, the Factorial calculator program. Now, really, I wanted you to work on the algorithm for calculating factorial, whether you do that with recursion or whether you do that with a loop. I wasn't so worried about that you're using this BigInteger library. That's why I labeled this under advanced mode. But some of you are keeners and you want to go out and get this done. So if you go to that BigInteger library, it's created by Matt McCutcheon, and he's actually kind of abandoned it. If you look at the bottom, you notice he's released this into the public domain. He's not developing it anymore. I'm going to zoom this in a little bit. We'll notice that it hasn't been developed for 5.5 years, but it suits our purposes. So there's a version from April 2010. There's a version from May 2009. I would guess we want the one that's from April 2010. There's a tar.bz2, which I know what it is, and a zip file. There's two choices. This one's smaller, but it's actually all the same file. So we'll just grab the zip because that's probably what most of you are going to do. Now I downloaded this to my downloads directory. Let's take a look at that. So I cleaned up my downloads so you don't see all my stuff. And there it is. So what I'm going to do, every project that you're going to make that uses BigInteger, you're going to want to copy this directory. Okay, the directory by default is called BigInt. So I'm just going to move that over here into my TC101 directory. There it is. And I'm probably going to rename this. It doesn't actually matter what you rename this. I'm going to call it WSQ09. It doesn't matter what you call the folder, it's just for your organizational purposes. All right, so let's open up this WSQ09 and we'll notice what's inside this folder. This is the library that came. It's not a library we install into your system. You don't try to install this into your system. It's a library we're going to use locally for now. It's got a bunch of C files and header files. We've talked about header files before. Don't worry right now if you don't understand what they are, but it's basically that the header file says what functions are implemented inside of the .cc file. It's using .cc instead of .cpp just because back then we tended to use .cc for C++ files and .c for C files, but the standard has changed, or the way we use C and C++, but it doesn't matter. So the real important files we want to look at are README. There's a README file. It says this is executable, but that's just not true. It's actually a text file, so I could open it with Atom. I'll open it up, and there it is. It's a big, long text file explaining the program. The other one that's really important is this sample, which is code that, oh darn, I'm opening it in Xcode. I don't want to open that in Xcode. Let's change the defaults for C files to open in Atom. I'll change all. I'll continue. And now if I double click this, it opens in Atom. I guess my Xcode took control again. We can take a look at this sample program. And what this sample program all it does is it's a main program. Well, notice we recognize these. We've seen these before, string and IOStream. This is different, the include BigInteger library.h. Notice it's in quotes, not brackets, and that's because we're including it from our directory where we're compiling. Okay, there's a main program. It's got a try-catch block, which you should probably learn about, but it's not part of this course. Defines a BigInteger, which is nice, and we can assign ints to BigIntegers. It's demoing that you can just put literal values into BigIntegers, and this is probably the most important for you for a couple reasons, mostly about the next project, the WSQ11, where you're going to convert a big, huge string into an integer. A big integer. Or you might want to go the other way around, convert from big integer to string. Probably to do input-output. When we input, we're going to read as strings and then convert it to a big integer. That's what this function will do for us. And when we're outputting, we might want to convert to a string before we print, depending how cout handles big integer. but it actually does. So let's take a look at that. It does a bunch of program, it does a bunch of output, and we can actually run this. So how do we run it? Well, here's the thing. There's this make file in here. There it is. Let's open this with Atom. I'll show you what the make file looks like. Relax. It's a set of rules and dependencies to make decisions to do things, really. And what we want, the things we want to do is to have it compile. This will be your key. If you want to reuse this library zip file for multiple projects, this is what you're going to have to change. Okay. What I really want to do is I'm going to change this later. So right now, let's just open up our shell. Let's go to that TC101 directory. Oh, there's the WSQ, so I'll switch to that directory. There's all my files, right? ls, lists files. Now, I'm not going to go g++ sample.cc like we've done before. This has a make file, so all we have to do is type make. And make knows how to compile everything together to make a program. So it compiled a bunch of library files. It's got a lot of warnings there, but remember this code's 5 years old, so there's deprecation warnings here. That's what that's saying here, deprecated. But they're all warnings. If this is production code, we'd get rid of those warnings, of course, but it's not. And it's putting together all of the object files, all these .o files, and creating an executable called sample. All of our executables before were a.out. Now it's sample. So I can run this program by diagonal sample. And it runs. What did it do? It printed a bunch of numbers. It printed numbers like 314 to the power of 10 is this big number which would not fit in a long or a long. So, okay, I can, but I want to do the factorial thing. Because let me copy over. I've got a copy of a factorial implementation over here. Okay, and I'm just going to compile it the old way, what we already know about. I'm going to compile my factorial.cpp. You want to take a look at the code? Okay. It's not that one, it's this one. It's factorial.cpp. And actually, let me close that and open this copy, not the original, because I'm going to want to change it here in a second. Where did it go? Oh, there it is. This is factorial. It's recursive factorial. That's the function. And the main program, all I'm doing is I'm going to print the first 25 factorials from 0 to 24 factorial. That's what I'm doing here. I'm calling my function and I'm printing it. Good. Let's compile it. We already did, and we'll run it. Notice 0 factorial works. Everything keeps going up by the previous, right? So we'll notice that 19 factorial is this, 20 factorial is this, which is multiplied by 10 multiplied by 2, the 12 becomes a 24, looks about right. But then I'm expecting that this times 21, that looks wrong, and that looks wrong, and this definitely looks wrong. What's happening is the numbers are overflowing. There's not enough bits, and it just, a bit falls off the end of the long, the unsigned long, and then the number's just whatever's left over. So it's blowing up. If you choose to use longs and not unsigned long, you'll notice it go negative, but I chose to use unsigned long to specify that we're not going to have negative values coming in or out of here. All right, so it blows up at about 21. Let's change this so it'll work with BigInteger. So what do I need to do? Well, I want to call my program Factorial, and I want to have it use the Factorial source file. So what I'm saying here is the name of my program is going to be called Factorial. I could actually call this Pizza Smurf or whatever I want. The real important thing is here, I want it built from Factorial's object file, the compiled object code. Now, our makefile knows how to compile factorial.cpp into factorial.o, and then at the end, generate everything. Generate the factorial program. So I'm going to clear. Notice all I did was I put my factorial CPP in this directory. I changed the makefile to have this whatever I want to call it, and I need to call this the prefix of the .cpp file. Now if I do make, it's going to compile. Notice it compiled our factorial.cpp and called it .o, and it only compiled it, didn't link it. And then it linked everything and created this factorial program. Ta-da! It still does the same thing. I haven't changed anything, but it actually linked all these libraries together to create the big, huge program, Factorial, which does nothing different. Now, here's where it gets more interesting. Let's actually update this. We don't want to use unsigned long. We want to use BigInteger, right? So I'm going to use BigInteger instead of unsigned long. So every place that I was using unsigned long, I'm just going to change it to use BigInteger. And I think that's it, because this integer I don't need it to be big because it only goes from 0 to 25. That should work, right? So I changed all the unsigned longs to BigInteger so it stores bigger numbers. And so I'm going to go and compile. Oh no, I don't compile. I use make, because make knows how to compile for me. Oh, unknown type BigInteger. Oh, what's different here? So how come it worked but mine? Oh yeah, I forgot. I need to include the library because it doesn't know what BigInteger is because it didn't include the library. So let's include the library just like it did in sample. Might as well close sample up because we don't need that anymore. So I include the library. So now when I compile, it knows what a BigInteger is and it should all work. Let's save. Let's make. Notice we got the warnings again because it recompiled those. No big deal. We got 5 warnings. And it did, if we look farther up, we'll see that it actually did compile our new version of our factorial. Good, it's happy. And because we included these other libraries, it started complaining about the deprecation warnings. And now we should be able to run factorial. First 25 factorials, they should get bigger and bigger, right? And they do get bigger and bigger. Look at that. It just keeps getting bigger and bigger. Let's go crazy. Let's do 50 factorials and see what happens. Make. That's cool. Now there's one little thing I want to show you. Let's change this program, okay? Let's change it to, because yours has to ask the user. We're going to print out which factorial would you like, and then we're going to do a cin to, I need to make a, let's make it a big integer. What the heck, they could type a really big one. Be kind of crazy, but oh well. Big integer n. And then we're going to read into n, and then I'm going to print n factorial is the factorial of this n. So I'm going to ask the user for the n. I'll let them give me a really big number if they want, so I'll call it big integer. So I'll read it into n, and then I'll print that value of n factorial. So let's try that. So clear, we're going to do make, and it freaked out. We got an error. There's an error. Where's that error? You've probably seen this before. There's this big, long string of errors, all linked to this single error. And it says, invalid operands to binary expression, iStream, and big integer. In other words, cin doesn't know how to deal with big integers. Cin can't work with big integers. So this is what I mentioned before. We're going to have to do a little bit of trickery here. We're going to read it as a string. We can input to a string. We've already done that. And then, now, remember that sample. Let's take a look at sample again. Where's sample.cc? Sample.cc gave us the trick. How did we convert a string to a big integer? Oh, we used this function. They happen to use s for their string as well, so I can just copy paste it. If I used pizza, then I would have to change all that to pizza, right? Should use banana, but I'll use pizza today. So I'm going to read in the string, store it as a variable of type string, then convert that string to a big integer, and then everything should rock. Make, well, let's clear it to make it nice and pretty. Make, compiled pretty fast. Looks like there's 5 warnings. We knew about those. Everything's good. It generated the output. Let's run this baby. So factorial. And now it asks me what number would you want. So let's put, we know that, what's 6 factorial? So remember, when you're running programs, you should think, what do I expect the output to be, and then check that it's what you expect it to be. 6 factorial is 24 times 5 is 720, right? Yeah, it's 720. That looks like it works. But we could try it with a big number like 50, and it works. We could try it with another big number like, we could actually technically type this number, and it blew up, segmentation fault. And that's because I'm doing a recursive function, and it ran out of stack space and blew up. So don't try to calculate that factorial because it'll never return. But we could do something like, say, 100 factorial. That's a pretty big number. Let's try 150 factorial. That's a pretty big number. Let's try 500 factorial. That's a really big number. So that's about all you need to know for how to use BigInteger, to be able to use BigIntegers in your factorial if you want to. It's optional, of course, and you're going to need this to work with Yo Soy 196. Come solve my Rubik's Cube. Come visit me in my office, IS5. Have a great day.